Hello, I am Lance, and my PhD project is in collaboration with CAEZ Pharmaceutics. We'll be looking at the dynamics of particles upon inhalation at high relative humidity. Firstly, I would like to provide some background information of this project. So the size of a particle is an important factor which determines whether it can enter the respiratory system and how deep it can deposit within the respiratory system. Currently, a lot of deposition profiles of inhalable medicines use the results from a cascade impactor, which characterizes the size distribution of the inhalable drug in its powder form, or also known as its bulk phase, at ambient relative humidity, which is around 40%. But when the patient inhales the drug particles become aerosolized and absorb water from the surrounding. As you can see from the plot on the right, the particles of higher hygroscopicity parameter, also known as kappa, takes up more moisture from the environment. Once the relative humidity surpasses 95%, the growth curve becomes extremely steep compared to lower relative humidities, and the human lung has a very high relative humidity. In the alveoli, for example, the relative humidity can reach 100%. The objective of this project is to explore the behavior of inhalable excipients and active pharmaceutical ingredients at above 95 relative humidity. This would help us develop a more accurate model for predicting the deposition profile of inhalable medicines. Comparative kinetic electrodynamic balance is a technique that can characterize the phase function of a single aerosolized droplet. It shines a laser beam on the levitated droplet trapped by an electric field, and the relative humidity can be controlled and set to close to 100%. As shown in the graph on the right-hand side, the data from an electrodynamic balance can be retrieved in the form of light intensity and scattering angles. Different morphology of the particle would result in a different laser refraction pattern. By pushing the relative humidity to 100%, we can mimic the relative humidity of the condition in the alveoli and hence know how the particle would behave in the respiratory system. Thank you for listening.